So today's subject is going to be to prevent elements from flipping over. So this is a sort of slab, and one of the main objectives of bracing is to produce a slab-like character, even if I'm working with skeleton constructions. So how could I brace this? I have some adhesive tape here, and I will scotch it to the table, and then I will tie it to the other side, and then it will stand up and it won't fall over anymore. This is because I created triangles on either side. So the basic construction would be a box. And well, here I'm designing a box. You can see that this box is open to above. So this is the box, and here I have the wind pushing against it, and you can see that it's not fully rigid yet. What would I have to do? Well, here I can deform it, and if I want to avoid this, I'm putting the upper part on top of it, and then it would be rigid. So I need one slab here in the horizontal and 3 slabs, that's the minimum, in the vertical. And the 3 slabs have to consist either of slabs themselves, concrete slab or so on, or they have to be braced skeleton constructions. So if I have only 2 slabs or slab-like elements, like for example in this case, there would be another slab on top of that, and the wind pushes here, then I would get torsion in this element. So this is why I need at least 1, 2, 3 sides that have to be braced, and a horizontal slab as well. 1 slab, 2 slabs, and a 3rd slab, and they have to be linked together by the horizontal slab, and then the whole thing will be rigid. And once I have the box, I can start to attach further elements to this rigid core, as I would call it, like for example here. Well, I could attach them to the core, but if I push here, this can still move in that direction. So I would have horizontal bracing as well as to attach it to the core. Instead of working with the core, I can also work with elements that I put in a peripheral position, columns and secondary structure. And then I need my 3 slabs or slab-like elements, and I need a horizontal link between them as to make the structure rigid. Here I don't need St. Andrew's cross, but I could put one for regularity reasons. So this is top news here, breaking news. It's a project of one of my students, a master thesis, and you can see that this student here has been conceiving a central braced jack, and then she has been suspending floors that are held up by these cables here, and the different levels here are braced by a peripheral truss, which creates the horizontal stability in this model. So very well done. She will succeed her master thesis. So let's talk about the slab in general. If it's a concrete slab, that's rather simple. I could also have a skeleton construction, posts and beams, and this would not be stable. So how can I create this type of stability? Basically, I'm dealing with too many articulations. The sketch I did before showed a system that had 4 articulations. 1, 2, 3, 4. And when the wind pushes here, the thing will flip over. So what I should be trying to do is to reduce the 4 articulations to 3. So I could introduce one here, so that would be 1, 2, 3, and 1, 2, 3. But this would mean that the diagonal would have to withstand to compression. So it has to be a strut. If I don't want the compression in the diagonal, because it's a long element and it will be subject to buckling, then I could work with a St. Andrews cross as well. So it withstands in tension when the wind comes from this side, and it withstands in tension when the wind comes from the other side. So I could work with cables here, while in the first case I need a diagonal strut. And here we have an example of student work where the 2 female students have been succeeding very successfully to create a rigid structure. So why is that so? Because they are working with triangles. Only 3 articulation in these triangles. So another method would be to create rigid angles. Like, for example, if I hold this ruler, it becomes rigidified by this encasement here of my hand. So the same thing we can do with columns. And then here I'm symbolizing this with the little triangles. And now I would be able to attach an otherwise articulated construction to this encased post. I could also try to do something different and create a rigid angle up here, so that I would reduce the number of articulations to 1, 2, 3, and this one would be fixed then. It would work as a frame. So in this case here you can see a rigid angle in a wood construction, and to rigidify it, these 2 sections, one being the column and the other the beam, have been bolted together with these steel bolts, and there's a screw in the middle to tie everything together. So the core construction is something you see frequently in high-rise construction. So the elevator and security staircase core, and then I could attach, as we have seen before, a skeleton construction to the central core, and then I could add a couple of levels following the same system. This is the most popular way to build high-rises. The objective being to link the high-rise floors to the central core, so that the whole system would be braced. Now I have one problem, that the proportion of this central core normally is around 1 to 7. Could be 1 to 10. And if I want to get higher, my core won't be big enough anymore to rigidify the building. So what could I do then? Instead of creating the core in the center, I could say my building skin is rigidified, and then the proportion here would be of the totality of the building in relation to the height, and then I can build much higher. So we'll fall over, and this happens by the horizontal slab.